Good morning, Adam. Good morning. Okay. So we can wait for 2 minutes, let other to join. Good morning, Shivam. Okay. I want to discuss the question of the midterm, but Sir has told me to discuss one more point today. That is one of the important topic. So on the Friday in the lab, we will discuss the midterm. Okay. So today we are going to handle about the one more important concept, that is purely mathematics. Therefore, be serious in this class and try to understand the mathematics behind this concept. Okay, that is one of the important topic, that is HMM, that is the hidden Markov model. You have to understand this topic today. Okay, so we can start this. This is purely mathematics part. So if you don't understand this part, you can't implement it. So be serious in the in today class. If you don't understand any of the little things, you can ask. Okay, so we start it or no? या मनु यार तुम आए नहीं यार। अरे सर जरा एक वो आ गया सर तुम पे अवार्ड दिलाना Yes, Monu. Actually, I want to discuss the midterm question, but sir told me that you can discuss on the Wednesday because you have the 2 hours. So in 2 hours, you can discuss the 30 questions and the assignment question also. So sir today told me to cover the HMM. Okay. Okay, so Monu. So on Friday, we will surely discuss about the midterm question. Okay. Friday, we don't have lab. We will discuss only on the, yeah, sorry, Wednesday lab. Okay. Sorry for today. I have not discussed. I have told about the midterm question, but I have not discussing it. But I have to follow the star instructions also. So on Wednesday in the lab, I will discuss that. So today we are discussing about the HMM. It is a very important topic, and if sir will also teach you this topic, but before sir will teach you, you have to understand the basic concept around this topic. Okay. So can we start? Everyone is okay with this? We can start the today topic. Okay. So that is the hidden Markov model. So before understanding the hidden Markov model, we have to understand this part. That is the Markov model. Okay. So we have to understand this Markov model. Okay. So this, first of all, we will understand this Markov model. Then we will have to understand the hidden part of the Markov model. So when we talk about the Markov model, it is used in probability. Probability, AI, machine learning, NLP, and various applications. Okay, so in the Markov model, we have to go through the three things. That is the Markov process. And first thing, second thing is the Markov property. And the third one is the Markov chain. These three things you have to understand. If you understand these three things, you will understand about the Markov model also. So each term, that is the Markov process, Markov property, and Markov chain, we will study in details. So today is 11th April. So this is slide 1. So first of all, we have to study about the Markov process. Markov process होता क्या है? So when we talk about the Markov process, it is telling that a stochastic process. Can anyone tell what do you mean by a stochastic process? What is the meaning of a stochastic process? Anyone? Anyone who can tell the meaning of a stochastic process? Okay, Rishikesh, somehow you are right. Go through each component. Okay. Anyone else? Any more of any more collection of random variable? Okay. Anyone else? Anyone else come with a new answer? Stochastic gradient descent, that is different. Here I'm asking stochastic process. Anyone? Okay, so whenever we are talking about the stochastic process, always remember it is a random process. Any random process. Okay. So in any random process in which the distribution of the future event only depend on the present state or present event without knowing how the present event has been arrived. Okay. So we can conclude that when we ask, we can conclude that future state depends only on the current state. Current state. Are you clear with this? So let us take one example. This is the current state. This is T. This is the current state. Current state. Now this one is the future state. Future state. That is T plus 1. And this is what? This is the past state. This is T minus 1. So Markov process telling that this future state only depends upon the current state. Okay, it has nothing to do with the past state. Okay, this is the Markov process. Markov process telling that future state is always depends upon the current state. It has nothing to do with the past state, and it has nothing to know how this current state has been arrived. Okay, are you clear with this? Everyone, are you clear with this Markov process? Okay, now next one, that is the Markov property. So when we talk about the Markov property, Markov property. So we have seen this diagram. This is T minus 1, and this is T plus 1. So this is x3, this is x2, and x1. Okay. So this we can say this is past, this is present, and this is future. Okay. So Markov properties, whenever we are talking about the Markov properties, tells that x3 depends upon the current state. It has no relationship, with past state. Okay, are you clear with this? So we can say that t plus 1 at the time t plus 1 depends upon on the t event, not how t event arrived. Okay, are you clear with this? So here we can say, whenever we are talking about the probability of sorry, wait a minute. So we can say that probability of x3, that is again it is wrong. P T plus 1 depends only on T. You got the point? The probability of T plus 1 only depends upon the T only, not the T minus 1. So this is known as transition probability. Okay, are you clear with this? Here when we talk about the state space, that is x1, x2, x3, which is also known as, or we can say that set of state. Okay, are you clear with this? Event, state, system, they are all same. Okay, are you clear with this? Okay, so next we can see the example. एक example देखेंगे. Example. So we have the weather conditions. It may be sunny, it may be rainy, it may be cloudy. So here, when we are talking about the cloudy, it only depends upon the rain. When we are talking about the rain, it only depends upon the sun. Okay, this thing you should know that. So this is S, this is R, this is C. This is known as event, or we can say that a state, or we can say that as a system. Any other example? We can see customer, next product. And we can see this is Nokia. Another we can see Samsung and iPhone. Means customer want to buy the iPhone by seeing the property of Samsung. Okay. Means from the Samsung they will go to iPhone. Means earlier they are using Samsung, now they want to feature planning, want to use iPhone. Same like with the Nokia also. And what is the current state of Nokia? Nothing. Okay. Same like we can see the infant baby. Okay, infant baby. Whenever we are talking about the infant baby, it is the playing, eating, sleeping, and this is crying. Okay, same way we can see the tourist city visit. What are this? A city, B city, C city. Game result. We can see lose, draw, and this is win. Are you clear with this? Are you clear with this example? Okay. यहाँ तक कोई डाउट है किसी को? Slide number 4. अब देखो एक एग्जांपल देखते हैं. We will see one more example. ये मान लो एक मेरा कोई स्टेट है. This is at the t-2 state. Another one is this. This is t minus 1 step. Another one is what? This is t. Another one is what? This is t plus 1. And another one is what? This is t plus 2. So we can say x t minus 2, x t minus 1, x t, x t plus 1, x t plus 2. So this is transited, this is transited, this is transited, this is transited. So this is known as what? This is known as Markov chain. ये क्या कहलाएगा? Markov chain. Okay. So if I tell you to find the conditional probability at t plus 1, so what will be the conditional probability? Can anyone tell? Xt plus 1. So the xt, that is xt plus 1, that is xt. This is okay. So conditional probability at xt. What is the formula? Can anyone tell? This is xt minus 1. I always told you that the future state depends upon the current state. Understood? So we can say that any chain that follow the Markov properties is called Markov chain. Understood? Everyone, are you clear with this? So in this example, we can say let x0, x1, x2 be a sequence of discrete, random, then x0, x1, x2 is Markov chain if it satisfy Markov properties. So here we can see everyone is following the Markov properties. So we can come with the general formula Pij. This is I or this is J. Okay. Are you clear with this? Or we can say this one is I. ये I है, ये J. So I to J. Whenever we are going from I to J, what happen? Pxt is equal to J depends upon xt minus 1 is equal to I. And this is what? This is the Markov property. Are you clear with this? Everyone. Markov properties, Markov process, and Markov chain. Are you clear with this problem or not? Okay. So again we can see more, that is the first order, second order, third order. Okay, so we will see the example. I told you this is what, this is x t minus 2, this is what, x t minus 1, this is what, this is xt, this is what, this is xt plus 1, this is what, this is x t minus 2, and all follows the Markov, this all chain follow the Markov property, that's why it is a Markov chain. Okay, now come with the first point, that is the first order Markov model. So the first order of Markov model, whenever we are talking about the first order of Markov model, means what? This pt, p, xt depends upon the current state. Second order Markov model, what will be the second order? That is p probability xt depends upon the t minus 1 comma x t minus 2. These two are the second orders. Okay. Now can anyone find third order? Third order at xt plus 1. Can anyone come with the formula? Third order. इस पे थर्ड ऑर्डर निकालो. What is the formula? Come with the conditional probability. Everyone, come with the conditional probability for the third order at xt plus 1. Rishikesh, Monu, Arnav, Virendra, I am asking for the find the third order, find the probability using the third order Markov model at xt plus 1. What is the formula? Are you getting what I'm asking? Arnav, अर्णव, समझ में आ रहा मैंने क्या पूछा है? Then tell me. Okay, I am telling that conditional probability using the second order Markov model at x is equal to t is probability of xt minus 1 comma xt minus 2. Same way, find the conditional probability using the third order Markov model at xt plus 1. That is xt plus 1. Okay. Bar sign is there, not divide sign. It is a bar graph, bar sign. Okay, Akash, it is not a divide sign. Or for all are using in your keyword this this is not there. Bar graph, see the sign above the enter. इंटर के ऊपर साइन है. इंटर एंड बैक स्पेस के बीच में देखोगे साइन आएगा. Okay, so it is what? Yes, Arnav, you are right. So this is what at this point it is p xt plus 1 xt comma पहले यहाँ पे गलत है, ये xt माइनस 2 नहीं होगा, पहले इसके पहले क्या होगा? एक्स टी माइनस वन होगा, फिर एक्स टी माइनस टू होगा। एवरीवन, आकाश इज राइट, अभिमन्यु इज रॉन्ग, एंड अर्णव आनंद इज ऑल्सो रॉन्ग। That is xt comma xt minus 1 comma xt minus 2. xt से पहले x, there should be a sequence it will follow. Okay, so Imanyu and Arnav, your formula is wrong. Okay, so now we will solve one problem. Example. तो कोई भी क्वेश्चन में एग्जाम्पल, दैट इज द सॉल्व प्रॉब्लम। तो कोई सा भी प्रॉब्लम में सबसे पहले आपको दिया रहेगा, दैट इज द फर्स्ट थिंग, दैट इज द स्टेट ट्रांजिशन डायग्राम। स्टेट ट्रांजिशन डायग्राम, ठीक है, ये दिया रहेगा। इट विल बी गिवन। तो वेदर कंडीशन हम लोग लेते हैं। तो ये मान लो मेरे पास क्या है, सनी। ये हमारे पास क्या है, रेनी। और ये हमारे पास क्या है, दैट इज द क्लाउडी। ये तीन कंडीशंस दिए हुए हैं। तो हमें देखना है कि सनी की जो भी है, आज सनी है तो कल की भी चांसेस सनी होने की, दैट इज 0.8 प्रोबेबिलिटी। आज सनी है तो कल कंडीशन हो सकता है कि रेनी हो, दैट इज द प्रोबेबिलिटी 0.15। और अगर आज सनी है तो कल क्लाउडी हो सकता है, तो उसकी प्रोबेबिलिटी क्या होगी, कैन एनीवन टेल? मैंने आपको दो प्रोबेबिलिटी बता दिया कि आज सनी है तो कल सनी की प्रोबेबिलिटी हो सकती है 0.8। ओके, आज सनी है तो कल रेन की प्रोबेबिलिटी हो सकती है 0.15। तो अगर आज सनी है तो कल क्लाउड की प्रोबेबिलिटी कितनी हो सकती है, कैन एनीवन टेल? अर्णव, अर्णव और 0.65 कैसे? अरे किसी भी चीज की प्रोबेबिलिटी इक्वल टू 1 ही होगी ना। तुम जोड़ोगे तो ये तो 1 से ऊपर चला जाएगा। इसकी प्रोबेबिलिटी होगी 0.05। किसी भी इवेंट की प्रोबेबिलिटी जो है कितनी होगी, 1 ही होगी ना मिला के। यस, 0.05। इसी तरह रेन का देखो, रेन का होगा दैट इज 0.6। ओके, रेन टू सनी it is 0.38. then rainy to cloudy how much, can anyone tell? अगर रेन टू रेन 0.6 है, रेन टू शनि दैट इज 0.2। ओके, नेक्स्ट वन वी कैन से दिस वन, ये देखते हैं, दैट इज क्लाउडी टू सनी इट इज 0.75। क्लाउडी टू क्लाउडी इट इज 0.02। देन व्हाट इज द क्लाउडी टू रेनी? ये 0.02 होगा, ठीक है। ओके ओके, आई हैव करेक्टेड 0.02। अब बताओ 0.23 क्लाउडी टू रेन। क्लाउडी टू रेन 0.02 होगा ना। ये कितना होगा? ये 23 किसका बोल रहा है? अभिमन्यु, आर गेटिंग कंफ्यूज्ड? ये 0.23 तो किसी का होगा ही नहीं। मैं पूछ रहा हूँ कि क्लाउडी से सनी जाने में 0.75 है, क्लाउडी से क्लाउडी जाने में 0.2 है, तो क्लाउडी से रेनी जाने में कितना होगा? दैट इज 0.05। ये आपको दिया होगा क्वेश्चन में। दिस इज द स्टेट डायग्राम। कोई दिक्कत है इसको किसी को समझने में? ये स्टेट डायग्राम एनीवन? किसी को कोई दिक्कत है? अगर मैं आपसे पहला क्वेश्चन पूछूं, फर्स्ट क्वेश्चन, टुडे इज सनी, देन व्हाट इज द प्रोबेबिलिटी of tomorrow will be sunny? Can anyone answer? By seeing this state diagram, can you say अगर today sunny है तो what is the probability of tomorrow will be a sunny? Anyone? Yes, that is the 80%. That is 0.8. That is the 80% chance है कि by this way, by this graph we can say that हाँ। ओके, तो पहला चीज हमने आपको क्या बोला कि किसी भी प्रॉब्लम में ट्रांजिशन डायग्राम दिया होगा। दूसरा हमारा है स्टेट स्पेस। कैन एनीवन टेल व्हाट इज स्टेट स्पेस और सेट ऑफ स्टेट? कैन एनीवन टेल सेट ऑफ स्टेट कौन क्या क्या होगा? एनीवन? एनीवन हु कैन टेल? यस, दैट इज सनी, रेनी एंड क्लाउडी। किसी भी सेंस पे ले सकते हो, कैसे भी आप ले सकते हो, कोई दिक्कत। ठीक है, आर यू क्लियर विद दिस? अब तीसरा चीज क्या होगा? तीसरा होगा तुम्हारा इनिशियल स्टेट डिस्ट्रीब्यूशन और प्रोबेबिलिटी, दैट इज पाई 0.8। इसको ले लेते हैं 0.7, सॉरी इसको ले लेते हैं we can take it as a 0.7, 0.25 and 0.05। ये हमारा इनिशियल स्टेट प्रोबेबिलिटी दिया हुआ है। तो किसी भी डायग्राम में मतलब कि इनिशियल स्टेट प्रोबेबिलिटी, initial probability of the sunny is 0.75, initial probability of rain is 0.25, initial probability of cloud is 0.05। ये भी 1 होना चाहिए टोटल। तो ये तीन चीज आपको देना जरूरी है क्वेश्चन में। पहला स्टेट डायग्राम, दूसरा स्टेट स्पेस और तीसरा आपका इनिशियल। ओके, आर यू क्लियर विद दिस एवरीवन? अब इससे हम निकालेंगे व्हाट वी विल कैलकुलेट द ट्रांजिशन मैट्रिक्स। क्या निकालेंगे? ट्रांजिशन मैट्रिक्स। तो देखो, दिस इज सनी, दिस इज रेनी, दिस इज क्लाउड, दिस इज सनी, दिस इज रेनी, दिस इज क्लाउड, दिस इज फॉर द फ्यूचर and this is for the current. Okay, are you clear with this? This is for the, this one is the future state, and this is for the current state. तो चलो ये बनाओ, ये डायग्राम देख के सब बनाओ. So sunny, from the sunny to sunny it is 0.8, from sunny to rain it is 0.15, it is sunny to cloud it is 0.05. Similarly, rain to sunny it is 0.38, rain to rain it is 0.6, and it is 0.02. It is 0.75, it is 0.05, it is 0.2. मिला के इसकी probability, whenever we are talking about this one, this probability should be 1, this probability should be 1, this probability should be 1. तो ये क्वेश्चन से हमने क्या किया, ये जब ये तीन चीज दिया हो तो हमने क्या किया, ट्रांजिशन मैट्रिक्स निकाल लिया. तो दिक्कत है? एनीवन? किसी को कोई दिक्कत है? ठीक है. एक मिनट से मैं सेव कर लूँ और उसके बाद फिर मैं आपको आगे पढ़ाऊंगा. हम लोग क्वेश्चन सॉल्व करेंगे. वन मिनट टू रिसोल्व द क्वेश्चंस. टुडेस क्या था? टेक्स्ट ऑफ लास्ट स्लाइड. एक मिनट. कैन यू सी दिस एवरीवन? एक मिनट से मैं छोटा सा करूँ. ठीक है? एवरीवन कैन सी दिस और नॉट? नो सर. क्या नहीं दिख रहा है? व्हाट इज? अच्छा चलो. अब देखो पहला क्वेश्चन क्या है. फर्स्ट कंडीशन, गिवन टुडे the weather is sunny, that is S. What is the probability that tomorrow is sunny and day after tomorrow is rainy? ये कंडीशन दिया हुआ है. अंडरस्टूड? ये ट्रांजिशन डायग्राम देख के का क्वेश्चन पूछा जा रहा है. गिवन टुडे द वेदर इज सनी, what is the probability that tomorrow is sunny and day after tomorrow is rainy? So we come with the solution. तो क्या कह रहा है अभी प्रेजेंट कंडीशन में T1 इक्वल टू एस, T2 इक्वल टू एस एंड T3 इक्वल टू आर, यही कंडीशन है। अभी आज जो है डे 1 पे सनी है, डे 2 पे सनी होगा और डे 3 पे रेनी होगा। ठीक है, तो ये जो चीज है, ये जो कंडीशंस है, ये इस पे डिपेंड हो रहा है और फिर ये इस पे डिपेंड हो रहा है। सो प्रोबेबिलिटी वी कैन राइट दैट इज T3 इक्वल टू आर कॉमा T2 इक्वल टू एस डिपेंड्स अपॉन T1 इक्वल टू एस। तो दिक्कत है इसमें किसी को? एनीवन? Now we can write this one as probability of T3 is equal to R depends upon T2 is equal to S into probability T2 is equal to S, T1 is equal to S। कोई दिक्कत है किसी को? Anyone? So what is this one? T3 R probability मतलब क्या? सनी से दिस वन, सनी से रेनी पे जाने पे, सनी से रेनी पे जाने पे कितना टाइम लगेगा, कितना प्रोबेबिलिटी है? 0.15 इंटू सनी से सनी जाने में 0.8, तो इट इज 0.12 इक्वल टू 12%। आर यू क्लियर विद दिस? ये वैल्यू कहां से आया? दिस वैल्यू हैज केम फ्रॉम द ट्रांजिशन मैट्रिक्स। दिस इज आल्सो केम फ्रॉम द ट्रांजिशन मैट्रिक्स। फ्रॉम sunny to rain, what is the probability? That is 0.15. From sunny to sunny, it is 0.8. So it is 0.12. Are you clear with this? Everyone? Okay. Now next problem you will solve. Slide 8. Next problem, it is yours. If today weather is cloudy and yesterday was rainy, that is R and this is C. What is the probability that tomorrow would be sunny? Calculate it. Have you understood the question what I told? If today weather is cloudy and yesterday was rainy, what is the probability that tomorrow would be sunny? This is the state diagram. This is the transition matrix. Calculate it. Everyone. Everyone calculate it. Anyone got the answer? And second question, third question. What is the probability of given series, that is sunny, rainy, then again raining, then again raining, then again cloudy, and this is cloudy. Zero point 0.015. So it is how much? On a percentage, it is 1.5%. Okay, right. That is right. Anyone others got how 1.5 came? Anyone can? Everyone understood? See, I am solving this problem. So it is telling that this problem, it is telling that T1 is equal to rainy, T2 is equal to cloudy, and T3 is equal to sunny. Okay, it is telling that today is cloudy, means ये cloudy है, तो yesterday rainy हो गया और ये sunny हो गया. So probability of T3 is equal to S depend upon T2 is equal to C, comma T1 is equal to R. So we can say that probability of T3 is equal to sunny is equal to the sunny, T2 is equal to C into probability of T2 is equal to cloudy and T1 is equal to rainy. So cloud से sunny जाने में कितना लगता है? Cloud से sunny जाने में 0.75 and rainy से cloud में जाने में 0.02. So it is coming 0.0150. 200.0216. No, Arnab, it is wrong. Everyone understood this problem? Slide 9. Now we will see the another problem, that is the series probability of given series, that is sunny, rainy, 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 cloudy, cloudy. So what is the probability of this one? PS. क्योंकि इसका इनिशियल तो कोई है नहीं तो ये PS ही हो जाएगा. इसका क्या होगा? Can anyone tell? This is PRS. रेनी जो है डिपेंड किस पे हो रहा है? सनी पे. इसका क्या होगा? PRR. इसका क्या होगा? PRR. इसका क्या होगा? PCR. और इसका क्या होगा? PCC. तो इनिशियल प्रोबेबिलिटी कितनी दी हुई है? दैट इज 0.7 इनटू सनी से रेनी में जाने में कितना लग रहा है? 0.15. रेनी से रेनी जाने में कितना लग रहा है? 0.6. 0.6. रेनी से क्लाउडी जाने में 0.02 इनटू क्लाउडी से क्लाउडी जाने में 0.6. So it will come around 0.001512. This is the answer. Arnav, can you verify your answer? Arnav. So I think everyone has understood this. So these types of problem will come. Now in the next class, we are going to see about the HMM. मार्कअप मॉडल आज हम लोगों ने पढ़ लिया, अब हिडन मार्कअप मॉडल हम लोग नेक्स्ट क्लास में देखेंगे। ठीक है, ये स्लाइड मैं गूगल ड्राइव पे डाल दूंगा। क्या पूछा अर्नब, 0.7 कैसे है? देखो पीएस जो है, पीएस का कोई इनिशियल तो नहीं है ना। ये देखो यहाँ पे अर्नब, ये जो सनी है, इस सनी का पहले तो कोई नहीं ना है, तो इसका इनिशियल क्या दिया हुआ था? यहाँ पे देखो क्वेश्चन में मैंने इनिशियल बोला था, तो इनिशियल 0.7 ही तो होगा, 0.15 क्यों लिए? इसका 7 होगा इनिशियल, तो इसीलिए 0.7। Okay, so I will upload this file in the drive. Kindly go through that. If you understand this, then only you can understand the Markov model, hidden Markov model. इसीलिए आप इसे समझिएगा, नहीं इसे फिर से देखिए घर। कैन यू सेंड योर ईमेल आईडी अगेन? मेरी ईमेल आईडी से क्या क्या काम करना है तुम्हें बताओ अयान, मेरे ईमेल आईडी से क्या काम है? पहले काम बताओ। व्हाट इज द वर्क ऑफ माय ईमेल आईडी? तो फिर मैं ईमेल आईडी बताऊंगा। ये मैं ड्राइव पे अपलोड कर दे रहा हूँ लैब सेशन में, सो यू कैन गो थ्रू दिस। सबको ये जो है काइंडली गो थ्रू न्यू फोल्डर, दैट इज आज टुडेज डेट है 9th। ये तो मैं डायरेक्ट अपलोड कर सकता हूँ, सॉरी, फाइल अपलोड, फोल्डर अपलोड। ये मैंने अपलोड कर दिया है। सर कैन यू सेंड मी योर ईमेल आईडी अगेन प्लीज? सर बाद में कुछ प्रॉब्लम होता है, so that's why in the next class you can write down the problem. In the next class whatever problem is there we will discuss. Okay, अब देखो ये मैंने अपलोड कर दिया है, जो भी मैंने आज पढ़ाया है वो मैंने सब अपलोड कर दिया है आपको। काइंडली गो थ्रू दिस ऑल दिस स्लाइड्स, तभी जाके आप हिडन मार्कअप मॉडल समझ पाओगे। Okay, okay, I am stopping the today recording, and by this I am concluding the today session.